Let me record on this computer. And so started recording. So there's a part in here where I said you don't even really need to know how to do this, how to set things up. If you just do your unit analysis correctly, it tells you how to set things up. You know what you need to start with, you know what you kind of need to end with. And so there is a part in here where I do things kind of stupid, but make me log into this quizzes. Okay. Oh, I need to enter code. So 653-369. I guess I could copy and paste this into the chat. That'd make things a little bit easier. Just in case. Here you go, everyone. Yes, no. There we go. All right, so I think it's time to start though. Okay. So hopefully you watched the video over 2A, but it is over doing unit analysis. And so we talked a little bit about, or in the video, I talked a little bit about how to simplify units. And so it is sort of like we simplify fractions when we multiply fractions and we cross simplify. So what we're looking for is one sort of thing on top, one sort of thing on bottom. How many slides did I have in this thing? Let me scroll down. There were, okay. All right, so they got a full question view. Using keywords, write out the 3 steps of the understand, solve, explain process when answering the following questions. So operations and units clearly. So the book likes to break things up into 3 steps, which is okay, I guess. It is the sort of 3 steps you should be taking when you work a word problem, I guess. But understand what they mean is they want you to read and understand the problem that's there, right? To pull out the keywords. Solving is where you're actually writing out, defining your variables, writing out your equations, and actually solving them is what they're talking about with solve. And then explain, so we're going to do some math. We're going to read, we're going to do some math. And then after you do some math, I don't just like want a number, right? I want a number and some sort of explanation of what the number means. So there should always be some sort of explanation. Maybe not so much here, but this section is all about units. So these problems, I'm going to be particular about the units that we're using. So how many buses are needed to transport 495 people if each bus holds 45 people?
So we're answering it by explaining how to do it? Or we're just
so for the computer, not so much. So for the computer, right, I don't really need to see this understand and solve and explain. It's really something you should just kind of like be doing, I feel like. I don't want to say it's bad, but it's not like, it's not something I put a really large emphasis on, but it is something you should kind of be doing personally, right? You should be able to read the problem and understand what's happening. You should be able to write some sort of equation and solve it. So I will be doing all that sort of stuff probably in the next step. So a lot of these I have the question and then I have it broken down. So I'm just trying to see, I'm trying to give y'all, let y'all have an attempt on your own is what I'm trying to do, right? Just kind of attempt to answer these questions, and then we will talk about how to sort of break it down and solve it. The explain part or something, I guess, on these questions, I want a unit. So it says how many buses are needed to transport 495 people. If each bus holds 45 people, so what we're doing is we're taking 495 people and dividing them into these buses, right? So I am hoping you can get the correct number from these two things. 495 and 45. So there should be a number. There should also be a word right after that number that describes what that number explains.
I hit the enter button too soon. I forgot to add my unit, and I can't go back and edit it.
I thought you could no, okay, maybe not. I thought you could resubmit.
No, it's what questions are they?
The open-ended.
Yeah, the open-ended questions. You can go back and rewrite those.
That's fine. What'd you get? 11. 11 buses.
Yeah, I got 11.
Should be 11 buses. Where are we at? 5 people away. Do y'all not want points? 5 people, 4 people not want points. You're dividing 495 by 45 is what we're doing here, right? And we get 11 is the number. The thing that we're talking about, the units here are buses. Let me look at it. I guess I just got to scroll through it. Doesn't sort them. Okay. And I think I saw someone describe it. Yeah, it's going to be really particular with the way it accepts things on the computer, right? It's really case sensitive. So yeah, that's what we're doing. But if we look at this, and let me get some annotations things up here. So if I'm looking here, and this is what I was talking about, this is an easy enough problem. You do not have you probably don't have to do unit analysis on this when you're doing this. You probably just say it's 495 people divided into 45 per bus. But if we wanted to do unit analysis, just to get our beak wet so we can get a bigger gulp later of it. What would simplify out in this equation? What unit would simplify out? Do we see it?
The people?
Yeah, the people, right? I got a people on top, I got a people on bottom. One of them's on top, one of them's on bottom. I got no more people here. So the people simplify out and I'm left with the unit of bus. So that's why I'm saying buses. This is on top. I multiply everything through on top. I multiply everything through on bottom. All I have is a bunch of other ones. So basically it's 495 divided by 45. Whew, excuse me. That's where we're getting 11. So we can do this with the unit analysis. I know it's one of those problems. It's probably easy enough to where you probably don't want to do it with unit analysis. It's why are we doing it with the unit analysis? Well, we do harder problems. they get more difficult. So just trying to get that set up there, I think. Area and volume calculation. So I believe this has 2 questions, and first part's first. I believe the first part says what? Find the area of the bed. So area and volume calculations, a raised flower bed is 30 feet long by 6 feet wide and 1.2 feet deep. So the first part is going to be find the area. The next part is going to be find the volume. So the area, hopefully you realize, area, we're looking overhead. We're doing what? Width and length, but not how far down it goes, right? Oh, I don't even need to calculate. What is on? We need a calculator for this. So this, you should put a number. That should be one thing. The other thing is you should put a unit on here. Surface area of the whole bed might be another way to look at it. What is that? The width and length, right, is the one that what we're really focusing on here. There are a few ways we can talk about the units that go on this thing. And hopefully I put in every single different way that you can spell it out. But if we're multiplying two things and they're both in feet, what is my area going to be in?
Feet.
By what?
Square feet.
Yeah, it'd be 2 feet, right? You get 2 feet, you get square feet. It's like the witches. I know they were remaking that movie, but it got a lot of flack. I don't know if they ever finished it. The old one was good, from what I remember. I hadn't watched it since I was a kid. But it was like, I think it was a Disney or Henson movie. I think it might have been both. It was called Witches.
Yeah, Witches. I think it's on HBO Max.
Yeah, they had square feet in that movie. I remember. Oh, man. Okay. All right, so I'll give y'all a few seconds more, but this should be like, it should be pretty quick. I'll give y'all like 30 seconds. This should be you're multiplying two things and you're putting in a word there. Okay. Ow. All right, so I gave some pretty strong hints, but if we're doing 6 by 30, that should give me 180. What are y'all giving me? 180 square feet. That's fine. That should be correct. Feet, it should be square feet. So it should be 180, and it should say something about square feet. SQFT, that's square feet. That's good. FT to the 2 is square feet. I tried to put it in all those, so I believe all those should have been counted correct. And if not, I'm sorry, but I guess you can blame the computers. And then now we want to find the area. And so we already know the area is what, 180 feet squared. So how do we go from area to volume? This one I might need a calculator for. I might be able to do it in my head if I really wanted to. I think someone was answering this in the last one. And now we have 1, 2, 3 units of feet that we are multiplying together. Yeah. So again, I'll give you just a minute to do this. I don't think it really requires a whole lot longer than a minute if you know what you're doing. Ah. Oh. Getting old and crickety. Okay, so we take 30, we multiply by 6, we get 180. We multiply by 1.2, so hopefully the number you have there is 216. The other thing, besides the 216, should be what? Feet cubed now is what we're doing in. We're doing volumes. We're talking about how many of those 1 foot by 1 foot by 1 foot little cubes, right? When we talk about area, we're literally talking about how many of these little square 1 foot by 1 foot little squares could we throw in this thing? How many can we pack in there, right? It's kind of like what we're asking. What was saying? 216 cubic feet. So this should be all pretty good. 216 cubic feet. I'm curious what people are doing wrong. I feel like wrong answers are more entertaining. Feet cube. That's okay. That's just a word of this thing, right? Usually we go with cubic feet or the symbol, but that's fine. Is correct. Where are we at? Identify the units of the following quantities. Oh man, this should take you 30 seconds after you read this question. Okay. Identify the units of the following quantities. State the units mathematically. For example, miles divided by hours or miles per hour. And in words, for example, miles per hour. Oh, I didn't notice it said and here. So if you just write it one way, it's fine, I guess, on this one. Your average speed on a bike ride found by dividing distance traveled by miles by the elapsed time in hours. So give me one way or another, either mathematically or in words. What your average speed would be. So what is your speed if you're measuring the distance in miles and the time in hours? And it seems like it's on here a whole bunch. Yeah, I don't know. Okay, I'll give you like 30 seconds on this, but it really it tells you right there, right? We're dividing miles by hours to get to what units. And I think this question is, I think, really just trying to get at like the vocabulary of things, right? Ooh, excuse me. To make sure you can interchange this word like miles per hour with this thing, miles divided by hours. When you see the word per, like in your brain, you're thinking division. I think that's really kind of the purpose of like putting this question in here. And so the units when you divide miles by hours is miles per hour. That's it. What else are y'all saying? Miles per hour. I don't know if it's counting it. It might count stuff wrong if you capitalize stuff. I don't capitalize stuff generally, so I don't know if it's counting it wrong, maybe for capitalization. But that might be a possibility. Miles per hour is going to probably count stuff wrong for spacing. I didn't put any spacing in this one. It's miles divided by hours. So it looks like everyone's getting it right. I don't know why it's counting maybe some stuff wrong. What did it say? Where's the chart view? There you go. Kind of one wrong for something. I don't know why. How much would you pay for 2.5 ounces of gold at a price of $1,200 per ounce? Okay, so if it has more than 3 decimal places, be sure to put your commas in there. This is sort of like if we're buying what, 9 apples for 10 cents an apple, how much are you going to buy, or how much are you going to pay? What are you doing to get that total amount? This is kind of the same thing. We got this amount and it's priced at this price per amount. If you do your unit analysis, you can also make sure you're in the right units. So I don't remember if I got this thing broken down. I feel like I broke this down on the next page. The slide 7. Oh, don't do this. Shoot. No, maybe not. Sorry. And be sure to put your units. Okay, I'll give you 30 seconds more, maybe 15 seconds more. That's probably more like it, huh? All right, so to find the price, if we get like 9 apples at what, 10 cents an apple, we do 9 times 10. So what you want to do is multiply these two things. So 2.5 by what, 1,200? Should give you what, 3,000, I believe, right? So what we're getting something like that, 3,000. What else are we saying? 3,000. I think some of these it may not be counting it right because of the comma. $3,000. So I know for a fact that I didn't ever put the word dollars in my responses in here, but it should have a dollar sign or it should have the word dollars. Okay. Questions about this? If you do your unit analysis, we have 2.5 ounces. This ounces would go on top. We have this many dollars per ounce. So if you wanted to divide this by ounces, I don't know why I'm doing it, but I have this thing over what, ounce. And when I multiply these two things together, I have 1 ounce on top, I have 1 ounce on bottom. That's going to give me something in dollars. Okay. Questions about that? About how to find that amount? So we do these sorts of calculations, this one, or something very similar to this. When you go to the supermarket, right, and you buy things, multiple objects of the same thing, or you buy something by weight, you have to kind of do the same thing. You multiply the two numbers, right? If your car gets 32 miles per gallon, how much does it cost you to drive 30 miles when gasoline costs $2.55 per gallon? So up until probably this problem, you might have been able, we're probably able to do it without unit analysis. This problem, unit analysis is really going to come in, and it will make things a lot simpler if you learn how to do it. And so that's what I would do on this thing. I would set up with the units. And this is the thing, I do it a weird way first. I don't know what to say. Just to show you can kind of do things with unit analysis. If you don't know anything else, you can start off with just writing your units. What does that mean? 32 miles. And like the name of the game is like, how do I get miles to simplify? What else is there that has miles in it? I see 32 miles per gallon. So 32 miles, and I'm dividing that by 1 gallon. I know I want to end up with what? Cost. I want to get rid of miles first. I'm probably starting it wrong, but it doesn't matter too much. So give this a go, try to get it worked out. And we're looking for a price. So most of the time, if I don't tell you, round it to 2 decimal places. And most of the time I tell you to round it to 2 decimal places. And then money, you should always round it to 2 decimal places because it's the nearest cent. Unless you're doing something a little more, what do I want to say? A little more specific, where the minute detail makes a difference, like in gas or something weird like that, where they count the 1/10 of a cent. Well, we don't typically do that. But did I answer this? I didn't answer this. All right, so I'll give you all a minute on this one. Oh man, y'all are missing out on getting an attempt on this. Try something. What's the worst part? You're gonna be wrong. You're gonna learn if you're always right. next class I'll show that. Okay, I think we're rounding it up. All right, so I'm on the next slide. I have this like it's not the right way to do it, but it's there to kind of make a point. I feel like that's definitely not me. 239. So it looks like some people are getting it. I want to see what else. What are y'all answering? That's not 239. 272. I feel like you might have went the other way with it. 11. It should be around 2 something, right? Because if 30 miles for 250, or wait, we're getting 32 miles per gallon and we're driving 30 miles, it should be a little bit less than 255 if you think about it relatively, right? But let's pretend like we have no idea what's going on. All you have to do is be able to write out your units on this thing. So I think the first thing, don't go too fast. The first thing I have here, I clicked too quick. But anyway, here we go. There is some lag here. Sorry. Let's go to the next slide. If you drive, here we go. If your car gets 32 miles per gallon. I don't know. Let's pretend like I don't know how to do this at all. I know nothing about this problem. But I know 32 miles per gallon, that looks like 32 miles divided by gallon. And this is not the right way to set it up. I'm just going to go ahead and say that. I will show you the more correct way in the next slide. There's another slide right after this. So I know I've got 32 miles per gallon. The next thing I see here is 30 miles. I don't have anything to compare it to, but I know I want to get rid of miles with miles. So I know I need to set these up like sort of like catty corner with each other, right? One on top, one on bottom. So that's the name of the game here. It's basically set one on top, one on bottom, get them to cancel out. I really shouldn't be putting things over one. I should be or under one. I should be putting them over one, right? So that's not exactly right, but it's an easy fix. And here's the final line. And if we look at how you might want to fix this, well, my miles are simplifying out with my miles. My last thing gives me dollars to gallons. So it's $255 for every 1 gallon. My gallons here with my gallons here. So I set my gallons up so that they're opposite of each other. And I end up with dollars on bottoms. So the only thing I really need to do is flip this around and I will have the correct answer. I got to do 30 times 2.55. And then I have to divide that by 32. I have to flip like this division operation around. But I have it pretty much set up, and it's set up pretty much correct. I could use that work, right, if I wanted to. It's not unsalvageable. And if you know how to do unit analysis, yeah, you can get to the next slide maybe. Next slide. It's going to go like 3 slides at once. I know it is. No, okay, there we go. So what you should really do is you should really start out with the information that you're given. So you want to drive so many miles and you want to know the cost of driving those miles. So input the miles, output the price. So the thing that we're really starting out with is the number of miles. And this is sort of like I was talking about. I want maybe this to be a fraction so that I have things in the numerator, things in the denominator, things on top, things on bottom. So you can always put things over 1. If I know I have 30 miles, I know I want to simplify out miles. The only thing else here that I see that has miles is this 32 miles per gallon. So if I want to know 32 miles per gallon, maybe you have a question of what order do I set this up in? Do I put miles on top or bottom? But what this thing tells me over here, this 30 miles, is that these things should be opposite to simplify out my miles. And then the last step, I have gallons on top here. I want to get rid of gallons, so my gallons have to be on bottom here. And again, going through our unit analysis, we have miles here, miles here. Those simplify out. Gallons of gallons. And we should be left with something with dollars. And this tells you the operation to do things in, right? So we want to do 30. We want to multiply by 2.55. So you don't have to memorize those stupid little big to small, multiply all, small to pig, divide the pig. Those help get you to a certain point, I guess, right? This will get you further. So this will tell you whether you're multiplying or dividing, if you know your conversion factors, which is, I believe, what we do in the next section. Next section 2B, we go into the U.S. customary. Oh man, make us learn a whole different set of measurements just for the U.S. But okay, we'll do it. Metric is so much easier to calculate stuff on. Consider the following exam questions and student solutions. This is the next slide when this computer wants to finally get around to doing it. There we go. And I don't need this thing open. Yeah. Maybe if I close some of this stuff, it might help a little bit. Wishful thinking, but there we go. So this is a student solution. Consider the following exam questions and student solutions. Determine whether each solution is correct. If it is not correct, write a note to the student explaining why it is wrong and give a correct solution. So this is going to be one of those open-ended questions. But if we look here, this is the exam question. This is their solution. So the question says a candy store sells chocolate for $7.70 per pound. The piece you want to buy weighs 0.11 of a pound. How much will it cost to the nearest cent? Neglect sales tax. So what I would probably do is figure it out without looking at the student's solution. And then I would look at the student solution and tell me why what they're doing is wrong. Because I'll give you that much. What they're doing is wrong. So what they're doing is they're taking 0.11, dividing it by 7.7 to get 0.014. And this goes back to the apples, right? The apple example. If I get a bunch of apples, I get so many dollars per apple, and I get so many apples. What am I doing with those numbers? And what did the student do? It's not what I want. Where's your responses? Try loading to see if it kicks the lag down a little bit. Freshen up a little bit. What is happening with my my power strip was off that I had my computer plugged into. Battery's just draining over here as I keep watching it go down slowly in the corner of my eye. I finally noticed it enough to there. All right. So what is the student doing that is incorrect? What should they be doing with those two numbers?
Should be multiplying the two.
Yeah,
numbers?
it should be multiplying those two numbers. If you multiply those two numbers, what do you get? How much are they going to charge you? It's not an even amount, so you probably got to round it. And you got to use a little context maybe to know which direction to round it. So how much are they going to charge you for your chocolate? Chocolate. Yeah, they divided the cost. They divided the weight by the cost is what they did, right? Should be multiplying it. So what number we get? How much are they going to charge you? Someone's, oh, there we go. 85 cents. Woo, no, careful. Don't do the 0.85 cents. It's 85 cents or $0.85. Right? If you combine those, that means a fraction of a cent. That's not good. There's a story. Some place was selling burgers or something for 0.01 of a cent. That's the same. Yeah. So they should be multiplying instead of dividing. You multiply the two, you get 85 cents. Man, just like, oh man, personally, like, I don't know, like when I started teaching, I really realized like how much the power of suggestion really sort of influences you. When you start grading people's stuff and they start doing things that are wrong and you just like nod your head and you're like, yeah, that looks right. No, that was way wrong. Okay. So no, it should be multiplying, not dividing. We multiply those two numbers, we get 85 cents. Questions about this? An air conditioning system can circulate 350 cubic feet of air per minute. How many cubic yards of air can it circulate per minute? So what are we doing? We're converting cubic feet to cubic yards. And this isn't something I necessarily expect you. Well, this one's pretty easy, right? There's 3 feet in 1 yard. You get a yardstick, there's 3 feet on there. That's probably on that chart that they give you in the next chapter, if I'm being honest. Not something I necessarily expect to be memorized, these conversion factors. But if there's 3 feet in 1 yard, what can we say about square feet and square yards? How many square feet? 3 feet in 1 yard, then there are how many square feet in 1 square yard? So if the single unit is 1 to 3, the square unit would be 1, 2. Yeah. What do we round to? It should be 2 decimal places. And how many cubic? So how many square feet are in a square yard? As it goes back to the unit analysis, we did talk about this a little bit back when we did geometry. Okay, I'll give you a minute, maybe 30 seconds more. 215. What did it tell me? 116. Someone told me 215. No. Yeah, it's not 3. I was trying to make that a point. As I was trying to ask for questions about, but nobody wanted to answer. 2 decimal places. So I think some people may be getting it, but they're rounding it. So round to 2 decimal places. Either that or they're pulling answers out of the back of the book because the back of the book doesn't round it as much as I do. So I don't know. But that's kind of the point. You shouldn't just be pulling answers out of the tuition's manual. It's not how you do a class. Okay, so how many square feet are in a square yard? Ooh, that'd be cubic. There are 20, yeah, the 9. Yeah, okay. So there are 9 square feet in a square yard. There are 27 cubic feet in a cubic yard. And the next slide, we'll look a little bit more about that. So this goes back to the dimension analysis that we talked about back in the geometry stuff. So we know we have, what, 350 cubic feet. Where's it at? Clicked it. Click it again. Here we go. So if you don't know, write it out. This is cubic feet, means that we have 3 feet there that are being multiplied. We know that there are, next bullet, there are 1 yard for 3 feet. So we can write this fraction. It is just converting. We're multiplying by 1, basically. We're multiplying by conversion. But if we do this, you might notice we have 1 foot here. That's going to get rid of 1 foot there. You have got something that is still in square feet times a yard. That is not cubic yards. So we still need to get rid of 2 more. So that's why we have to do this. So this is going back to what we learned in geometry. It's trying to bring around what we learned in geometry. The fact that if we have cubic feet, 1, 2, 3, we're going to have to do this thing 1, 2, 3 different times to get to cubic yards. And so when I was talking about 1 to 3, right? Let me just do it in text. That might be easier. 1 to 3. And this is if it's single units, right? The other thing I was talking about, what, 1 to 9. Where am I getting that 1 to 9? That's 1 to what, 3 squared? So you have to square the conversions for square units. The other thing, right, 1 to 27. Where am I getting that 27 from? I'm getting from 1 to 3 to the 3rd power. And this is for cubic units. So you have to cube the factor when it's cubic units. This is a little bit of a justification for why we have to do that, right? questions about this? And this might, I believe this does come up later. This is something you definitely got to get down. Okay. Next slide. So that is doing the dimensional analysis. You have to multiply by that dimension multiple times, depending on what dimension you're in. Your dinner in London. Okay, here we go. Let's look at here. Your dinner in London cost 82 British pounds. How much was it in US dollars? So this is something, and if you're doing it, you probably don't want to go look at a table from 2017. You probably want to look at a recent table, right? These things change daily. They change, I think, by the second, to be honest. But these rates change pretty dynamically. So you have to look what it currently is when it was the last time that you can look it up. This is dollars per foreign. So let me do this maybe with a little bit of drawing. So this is dollars per foreign. So what they're talking about is that this is American dollars per British pound. I should have done a different one. I'm going to make this one too easy for you if I do this. So if you wanted to write things in, you could write these words in. I should have done it with text. It would have been easier. Or you could do it the other way around. So I talked about this in the notes a little bit. But these things are what you might call reciprocals of each other. If we put them over one, if we put one over that number, we will get that. But this is pounds per dollar or foreign per dollar. So we start out with 82 pounds. And so we're either going to multiply by one of those or divide by the other, but I'll give you a hint. We're doing pounds. So we should be in this row right here. So if we want to do Canadian dollars, it'd be this row. They got what, euros, yens, and pesos. The other thing I've heard from traveling is if you're traveling and then you definitely want to sort of figure these things out by yourself before you go to the ATM machine to go get your money out. A lot of those ATM machines, from what I've heard, are like kind of tourist traps. They don't actually give you like the exact like transfer rate that they're supposed to. So these are things that you might actually have to figure out on your own at some point if you do some traveling. If you're a manager that manages any kind of finances, right, and you got a team that's doing traveling, you're gonna have to do something like this. And I know you can probably put this in Google and figure it out, but you may not have signal or something like that. You might have to be relying upon your old price that you have on your phone or something.
So the dollars per foreign is US dollars. So every British pound is 1.221 US dollars. Is that what it means?
Yes.
Yes. Okay, thank you.
It means those two things are equal. It means we could write a ratio with those two things in there. Or $1 is 0.8191 pounds. 1 pound is $1.221. Okay, so I'm going to include those drawings. So we start off with, did I even answer this on my thing? We start off with 82 pounds, and we want to know how many dollars that is. I didn't even answer it. So I think I'm almost. So either multiplying or dividing by one of those numbers or the other. So you kind of, you have to go the right way, right? There's two right ways to go. There's two wrong ways to go, basically, is what I'm saying. And we should end up with an answer that is in dollars. So for everything that I did in dollars, I used the dollar sign and I rounded to 2 decimal places. And maybe you might need to use a little bit of discretion. But you can do this with the unit analysis. Did I set up a different page or did I just jump? Team, don't click on the thing itself. That would be horrible. Okay, so I think I have it. Yeah, I have it set up after this, broken up a little bit into how to do this. But this is the problem. So give it a roll, like try to multiply or divide by one of those things. Let's try to set it up to figure it out with some unit analysis. But I'll give you a few more seconds. How many total did I have? 15 out of, yeah. All right, so you're starting out with, so write it down, 82 pounds. If my pounds is not a fraction, if I want to make it a fraction, I can always divide this thing by 1. If pounds are on top, these are the numbers I'm using. And I had the fraction written out just a second ago, but this is my dollars divided by 1 pound, or this is my pounds divided by $1. You can use either one, and it should give you within like two decimal places is what it will give you probably, because those numbers are rounded themselves, so they might be a little like a cent off or something. But okay. Oh, what happened? I didn't hit end, did I? Okay, so you gotta set it up right, but it should not take you too terribly long to multiply or divide by a number. What do I do? I want to see if someone gets 67.16. If you did that, you went the other way. I want to see. Did someone do that? Why'd they put this button like right there where the scrolling bar is? I saw one. Ooh, so some people are going the other way. If you do your unit analysis, hopefully that will keep you from doing that. So if we look at our unit analysis, we start out with 82 pounds. And this, I talked about it, is dollars per pound. So if we want to set this up, come on, next bullet. We can set it up with this 1 on the left over here, which is the 1.221. If we set it up this way, I want my pounds up here to simplify with my pounds down here. So that's if I'm using the 1.221 number. If not, I can use the other number. And so I'm either multiplying by 1.221 or I'm dividing by 0.8191. Either way, you should get the same answer, right? You should be getting the 100.12, I believe is what it was. And if I'm being honest, you could probably just like completely black out one side of this table if you wanted to. Like you really only need one side of this table, because this is the same as this. It's just the opposite reciprocals, right? It's sort of like dividing by 2 is like multiplying by 1/2. So this would be like multiplying by 2. This would be like dividing by a half. You're still doing the same thing. Did I say that right? Dividing by 2 is the same as multiplying by a half. Might be the easier way to think about that. Just say it that way. I think I might have said it backwards. Okay. So this is what this should sort of look like. You want to end up with the dollars on top. You want the pounds to simplify. If you end up with dollars on bottom, you just got to flip things, right? Okay, so gas price. This one is a little more involved. But it is the same concept. I think they throw in maybe like one more extra step. Gasoline sells for 1.5 euros per liter in Bonn. What is the price in US dollars per gallon? And 1 gallon is 3.785 liters. So we want to convert what? Euros to dollars. We want to convert liters to gallons. So again, I'm looking at this table. We don't need to use like the whole table. Oh man, this team is all like, let's exit that. So hopefully you're using that either that 1.058 or that 0.999449. Start out with what you know. What do we know? €1.5 per liter. €1.5 per liter sounds pretty cheap. All right. So you actually know what it is, probably. So I think it's probably like one of the points of this problem, right? If you go to Europe, they're going to measure things in euros per liter. What is that? How's that compared to the gas prices over here? Is it the same as saying that's $1.50 per gallon? Not quite, right? All right, so there are two things that we're converting at once. So we'd have to do a money conversion, and then we have to do the liters to gallons. Did I do it right? And as always, round it to 2 decimal places. Okay. Yeah, that last one. The last problem on here is fairly long. It's not too long. I'll give you a few minutes on this. Oh, where you at?
I'll be right back. I gotta get some food.
Yeah, I had my coffee caught up to me. I was hoping y'all be done with this by the time I got back. So we got to convert euros to dollars, and we got to convert that liters to gallons. So again, looking at this table, you should be using this row that says euros. So hopefully you're either using that 1.058 or what, €1 is what this is telling me. Or the other way around is I have 0.9449 euros for every $1. So one of these is one that you want to use. You can use either one. I know I have the fraction like this way, but I guess I could technically have the fraction the other way. It's saying these things are equal to each other, right? And so either way that we put our fraction, it's like having that big fancy one that you're not changing things, you're just changing the units. So I think I went with this one is what I did personally. I think I might have did that in the notes in the next page. And so we're either multiplying or dividing by this number. And then the next thing is we're either multiplying or dividing by this number. So there should be 2 numbers. I guess 3 numbers that you're multiplying or dividing by. It takes 2 numbers to multiply. And then we're doing it one more time. I gotta clear my annotations. And exit out annotations. How many people have answered? Oh man, where y'all at? Come on. I'll give y'all 30 more seconds. All right, we gotta get through this. Did I submit? I don't know. I guess I did. All right, so it should be 601 per gallon. So what are we saying that people that did answer? My brave. 6, okay, close enough. 601 per gallon. 601 per gallon. 568. It looks like you maybe went around the other way when you were doing your money conversion, if I had to guess. So it looks like you maybe flipped a money conversion. 601. It looks like a lot of them are getting 601. 245. Looks like you flipped maybe both of your conversions. Or maybe one, not the other. I think that's what it is. You flipped the gallons, but not the other one. All right, so the next slide, I'll break it down here. We start with 1.5 euros per liter. So there are two things I need to do here. The first thing is to convert euros to dollars. So I believe I use this 1.058. And I know it's $1.058 to every 1 euro. The other question is, like, what order do I write these things on? Do I write dollars on top, euros on bottom, or vice versa? Because I can flip these, but I want them in this order so that this euro is on top and this euro is on bottom will simplify out. This one might be a little bit different than what we've seen so far, maybe a little bit, because the liter over here is on bottom, and I want to get rid of this liter. And so to get rid of this liter, I have to write the liters on top over here. So that might be one of the first ones where we actually want the unit on the bottom. But if we look at the units that we end up with dollars on top. We end up with gallons on bottom. Everything else is crossed out. This is going to give us something that is in dollars per gallon. So that is how gas is priced over here in the States. And so what this is telling us, if we do our unit analysis and set things up, it tells us the units that we end up with. And it also tells us that we're multiplying all three of these numbers together. So if we multiply all three of these numbers, what do we end up with again? 601, I believe, right? So 1.5 euros per liter sounds like it's a really good gas price until you actually convert it to $6 a gallon. Then you realize it's heckin' expensive. Clear my drawings so I don't get the scribbles on there. All right, so suppose your car averages 38 miles per gallon on highway in 55. Okay, so this is the one they're like setting it up. Suppose your car averages 38 miles per gallon on the highway if you're driving 55 miles per hour, and it gets 32 miles per the gallon if you're driving 70. So what is this saying? If I'm driving faster, my gas mileage is not going to be as good, is basically what this is telling me, right? The quicker I go, the less good my gas mileage is going to be. This, we're not even going to use it for the part A. Part A says, what is the driving time for a 2,000 mile trip if you want to drive an average speed of 55? And then the next part for part A is, what is the driving time at a 70 miles per hour? So first we're going to do 55 miles per hour. I will give you a hint. If you do your unit analysis, we want to know time. We know there is a 2,000 mile trip. And we know we are going at 55 miles per hour. That is 55 miles for every 1 hour. And I believe 2 decimal places, right? Is what we're gonna have to do. So give me a number, give me a unit. And so the first thing they ask is, what is the driving time for 2,000? I can't speak anymore. What is the driving time for a 2,000-mile trip if you drive at an average speed of 55 miles per hour? Yeah. Don't. I really don't feel like this problem should be taking that long. I feel like a lot of y'all are tuning out or something, like at the end, and like we're like at the last problem, like, and y'all are lollygagging on this last problem. It's like, come on, man.
I
There's
don't know what it is about math. It's like anytime I have a problem in front of me, it takes like way longer to figure it out.
All right, so write this out. 2,000 miles, 55 miles, and then there should be a division bar, and on the other side of that division bar, there should be 1 hour.
Okay.
And there's basically two numbers there. You're either multiplying these two numbers or you're dividing these two numbers. So that the unit analysis should tell you which way it goes. It should tell you that you end up with hours because the miles will simplify out. And so what I believe we're doing is dividing those two numbers. 36.36 hours. Thank you. There we go. Come on. And I think I have a slide detailing it, but we're dividing those two numbers is what we're doing. 2,000 divided by 55. Do I have a slide? I believe I have a slide that like shows it. So hopefully. Yeah, here it is. So if we just know 2,000 miles and we know 55 miles per hour, maybe we don't know that maybe we were supposed to flip this thing. But what tells us that miles should go on bottom is that we got the miles up here. And all in all, this should end up with something that is in the units of hours. So this is telling us to divide it. One's on top, one's on bottom. It's telling us we should end up in hours. And so it should give you something around like what, 36.36. With that knowledge, this one I'm giving you 30 seconds on, no more, no less. Now we're answering the other part of that question, which says, what if we drive 70 miles per hour? Okay, so this is the exact same process that we did last time. We're going to take 2,000 divided by 55 miles per hour to figure out how long it takes to travel 2,000 miles an hour at 55 miles per hour. If we want to know 70 miles per hour, we take 2,000, same process. We're dividing it by 70. And instead of 55, now we're dividing by 70. Okay. And then we got one more question that's a two-parter, I believe. Believe is what it is. Now we want to know, what is the gas cost for a 2,000-mile trip if we drive at 55 miles per hour? So this is going to be a two-parter. Each of these is going to be a two-part conversion, I believe. So I will give you a hint. We're driving at 55 miles per hour. We don't actually ever use that number. I believe we use this number, 38 miles per gallon. I believe we use the fact that each gallon is 255. And we use the fact that we're taking a 2,000-mile trip. So I think we start out with the 2,000 miles, right? That's kind of like the input. And we want to output a price. It's like input a number of miles you're going to drive. Everything else is just a conversion factor, excuse me, or a rate. So let me make sure I'm setting it up right. Give y'all a minute on this. And first, we're going to set it up with the 55 miles an hour, which is the 38 miles per gallon. And then the other thing is we're driving 255 per gallon. Start out with 2,000. We're doing something with 38. We're doing something with 255. What are the costs when you drive 2,000 miles? These are something to compare when you may have to buy a car. Yeah, oh man. Had to buy a car a couple years ago. Those life events. Start calculating those trips and how much electric costs versus hybrid versus gas. All right, we're at 30 seconds. Housing and transportation really are like the two biggest costs, I believe. You're spending money on a house or a car. Those are your two biggest purchases you make in your life, pretty much. Most people. All right. We got one more question after this one. So this one, what did y'all get? Did I not get it? Did I do the right numbers? I forgot to put my dollar sign. That's what I did. Okay. 134.21. It seems like some people are getting it. 134.21. That was probably me with the dollar sign in there. 140 seems close. I'm not sure what you are doing to get 140. I think maybe I might have used the other number, the 32 instead of the 38. Maybe, I'm not sure. I'm not seeing off the top of my head where that went. But hopefully when you look at this next slide, you can see where it's coming from. So this is, like I was saying, we want to start out with 2,000 miles. If we don't know what to put something over, we can always put it over one. Oh, come on, bullet. So I start out with the 2,000 miles. The next thing that I want to talk about is the 38 miles per gallon. So maybe I don't know which way I want to write that, but I know that I want my miles to simplify with my miles. And so then after I know that, the rest simplifies out. I know I want the 38 miles to the 1 gallon on top. The other thing is the $255 per gallon. So I want my gallons to simplify out. So that tells me what order to write that thing in. And the last thing that I'm looking at is I got my dollars left over on top. So I'm multiplying 2,000 by what, 2.55? So I'm multiplying those two numbers, and then I'm dividing by this 38. Or you could do it in a different order, maybe 2,000 divided by 38 multiplied by 2.55. So there's properties we know about multiplying, dividing that might come into play here. But this is what this problem looks like. So this is if we do it at 55 miles per hour, we get 38 miles per gallon. If we go 70 miles per hour, how does that change this problem? This is still going to be the same. Our price of gas isn't, we're not going to get cheaper gas just because we go faster. This is still going to be the same. So this thing is the thing that should change from 38 to, what's the number? 32, I believe is what it is. Oh, where are you at? Yeah, you obviously lost your connection. You bring up the last question. Okay. Last question. I kind of already said how to do it. You should have put your dollar sign. And I'll give y'all like a minute to do this. I already said how to do it. It's 9:30. Okay. So it should be what? 2,000. We multiply it by 2.55. And now instead of dividing by 38, we'd be dividing by what? 32?
Why? On the last question, does my calculator decide to be stupid?
At least it waited until the last question and not like the middle. Could be worse, I guess. So could be better not to do anything. But all right, should we be getting something like 159.38? Should be what we're getting here. Any questions? We're already over. Didn't my one person come? That's what I gotta look at. All right. If there's no questions, that's all I got for y'all today. Be sure to watch 2B turn into A. I will be getting things turned back graded shortly.
What was the answer for the other question?
Which one?
The
159.
last one we just did, because it didn't pop up on my screen.
159.38 is what it should give you.
Okay, thank you.
And I'll stop sharing and I will stop recording.